So this will be the beginning of part 2 for section 4.3, and we'll pick things up on number 3. Okay, so after doing problems 1 and 2 where they gave us the function, we now need to switch our focus and realize that they have in fact given us the graph of the derivative itself, not the function. So now they want to know when is the function increasing, and so that would be, again, in terms of looking at the derivative now, not like here from -1 to +1, not this, because this is the derivative. We want to know when it's increasing, and that would simply be when the derivative is positive. So we look at our picture, and the derivative is positive anytime we're above the x-axis. So it would appear that the answer should be, when is the function increasing? When its slopes are positive, and its slopes are positive from -infinity to -1, or from 0 to 2. That's when the derivative is positive. This is the derivative. So we're not looking at the slopes of this picture, we're in fact looking at the values of this picture. So when is the function decreasing? That would be whenever the derivative is negative, and my derivative is negative from -2. Let's see here. I put -1 earlier, so it's increasing. That should be a -2. My apologies. So when is it negative? Looks like from -2 to 0, or from 2 to infinity. So then the question is, where do we have local extreme values? We have local extreme values at the critical values, and the critical values are when the derivative equals 0. So where is my derivative 0? We have it x equals -2, x equals 0, x equals +2. And let's just take the extra step and identify what kind of local extremes they are. -2 changes from positive to negative. So again, these are slopes. So positive slopes to negative slopes makes that a local max. X is 0. We switch from negative slopes to positive slopes, and that makes it a minimum. And x equals 2, we have positive to negative, which means we're going up and then down, so that makes it a maximum. Alright, so technically that's all the book asks, but I think we're missing an opportunity to now talk about concavity. So, a function will be concave up when its second derivative is positive. So the question now becomes, when is a second derivative going to be positive? Since a derivative tells you about the slopes, we need to really be thinking about now the second derivative, which is the derivative of our picture. So we have the first derivative, we want the second derivative. So in order to do that, we have to think about the first derivative's slopes. So if I were to take the derivative of this picture, then anywhere this picture is decreasing, so from -infinity to -1, the slopes here, now we're looking actually at the slopes, not the values, the slopes are negative. So that would translate to a second derivative that was negative. So I am going to be concave down in this section from -infinity to -1, or from 1 to infinity, because that again is where this picture has negative slopes, which would translate to a second derivative being negative, because a derivative again always tells us slopes. So where are we going to be concave up? That'd be when the second derivative is positive, and the second derivative is positive when the first derivative is increasing. So that would simply be from -1 to +1. Alright, I encourage you, if you haven't done so, try number 4 on your own, pause the video, and again, attempt D and E and think about the concavity. Alright, so after you do that, then start the video up again. Alright, so assuming you followed my instructions, here we are at problem 4. So the function itself is increasing when its derivative is positive. The derivative is positive, it looks like from -2 to 0 and or 0 to 2. We don't want to say from -2 all the way to 2 because at 0 the value appears to be 0, which is not positive. So therefore we're not increasing there. Where are we decreasing? Wherever my derivative is negative. So that would be from -infinity to -2, or from 2 to infinity. That's where my derivative is negative. This picture has negative values. So where are my local extremes? X equals -2, x equals 0, x equals 2, same as before. And what are they? Negative slopes to positive slopes. Negative derivative, positive derivative. So that would be negative to positive. That means a minimum. We're going negative and then positive, so we have a minimum in between. At x equals 0, we have positive slopes, because we have positive values, to positive slopes. So what that tells us is we were increasing, so our slopes were positive. Briefly, our slopes became 0, and then afterward our slopes were positive again. So what I have here is not a local min or a local max, and in fact I need to come back here and scratch it off because it's not a local extreme value. Positive slopes to positive slopes. We didn't turn and come back down. At net +2, we have positive slopes heading to negative slopes, so that's up to down. That makes this a local max. Okay, somehow I've rambled on for over 7 minutes already. So, oh, wait, can't stop yet. Let's do the concavity. Concave up is when the second derivative is positive. The second derivative is positive when the first derivative slopes are positive. In other words, when we're increasing. So this function should be concave up from -infinity until what I'm estimating to be -1. And then again from 0 to +1. Slopes are positive, the actual slopes of this picture now. And then concave down when the second derivative is negative, or where the first derivative has negative slopes. So concave down from -1 to 0, or from 1 to infinity. Okay, now we'll stop part 2, and I'll see you on part 3.